ท่านหนึ่งนะครับในงานนี้นะครับอยากให้ท่านผู้ชมมาพบกับดร.เจิ้นต้าช่ายนะครับดร.เจิ้นต้าช่ายเนี่ยก็จะเป็นคนไต้หวันนะครับจบจากไอโอวาสเตทนะครับแต่ตอนนี้ทำเรื่อง AI เป็นบริษัทส่วนตัวนะครับแต่วันนี้จะมาพูดถึงว่าการใช้ AI ในทางด้านการเกษตรทางด้านโดยเฉพาะ climate data เนี่ยนะครับโดยเฉพาะภูมิอากาศนะครับของข้อมูลทางภูมิอากาศเนี่ยทำอย่างไรเดี๋ยวมาติดตามชมกันครับว่าน่าสนใจอย่างไรครับในมองโลกมองเกษตรครับ
May I start with Dr. Chai first under the topic of cultivation innovation, climate assisted agriculture forecast using emerging AI platform. This is very hot issue, please.
Okay. In this morning, you must hear about the climate change can impact the cassava yield, right? So now I'm talking about agriculture climate system with AI in mind, which is developed by the Kasetsart University, the Climate Intelligence Center. Okay. So my name is Jenq-Dar Tsay, and the key person of this project is Professor Simon Wang, but he cannot come here today. So I came to give a speech and give a talk and discuss with everyone. And we were close friends and classmates since the graduate school in Iowa State University. So after the graduation, he became a professor in the climatology, and I working for the IT company for Taiwan. Okay, and we have been doing some interesting projects. For example, like the agricultural weather monitor system and the wildfire weather index forecast system. This one is cooperated with the Zhongxin University in Taiwan, mentioned by the Professor Wayland in the morning. And we are working about the AI weather tripper and the AI climate season forecasting. Okay, so next we will discuss about climate change in the agriculture and how the climate data and AI can help in this presentation. And in the beginning, I was talking about the climate change impact on agriculture. And this part, I will go through very fast. And so I will leave the time to talk more detail about the system developed by the Kasetsart University. Okay, so this is the challenge of the climate change on the crop. So the post-1988 co-breeding has improved yield and the drought tolerance through the molecular breeding. Okay, so, but like some climate extremes, for example, like the 2012 drought in the United States, have exposed the vulnerabilities of the within the agriculture. So the increase in irrigation is becoming copy mechanism. This highlight like the growing dependency. So on the drought tolerance, the breeding advance won the first round, while the irrigation won the second round. So reports from the Lois and the World Economic Forum emphasize that the extreme weather and climate variability are critical to affect the food security and global economics. So the government data shows like 20% cassava yield drought during the drought years. For example, like 2023. Okay, so the soil moisture in the Thailand has a strong relationship with the cassava yield. And the drought is strongly related to the circulation anomalies caused by the ENSO, like the ocean heat and the convecting rain here and through the water circulation, downward motion. So this is the dry up. Okay, so an AI model used the ocean heat and the soil moisture 6 months before and has predictor can improve the drought relative yield forecast. The drought index suggests that not only the region become drier on average, but the frequency and the intensity of the extreme drought are increasing. Like, okay, so this photo reminds us the devastation 2011 flood, and this increased the hydroclimate variability close to the ENSO variabilities. So weather is important, but how many stations are there? So what if we can access such data everywhere? Okay, we can use the modern reanalysis. So there are a lot of types of climate data like remote sensing and the surface observation. We can combine the past observation and the numerical weather models to provide a consistent historical climate data set. Okay, then this slide will show you the power of the data assimilation. So here, no observation, right? And observation. And through the data assimilation data, you can get the data here. Okay, we can use the satellite image to validate. So we can see there's a dust and the low cloud here, and we can see the cyclone here. Okay, so there are 7 challenges facing the plant breeding, and 4 of them can be helped by the reanalysis data. So reanalysis data and the climate data explanation can support the plant breeding research by offering the long-term and the special detail insight into the climate influence. And these 2 examples show how the climate data can improve the palm oil yield with the advanced season predictor. And the other one shows the climate data can be used to select the breeding heat-resistant rice varieties in Taiwan. Okay, also the early warning system involved by the climate data can alert the breeders to impending the climate extreme. For example, like these 2 systems. Okay, there's opportunities here. First is the climate data reanalysis everywhere through the reanalysis data. And second is the seasonal forecast. So we need a global data, huge. In the traditionally, right now, we need to use, due to the limitation of the computing power, we need to use the physical-based, the regional climate model to increase the resolution of the global climate model. This technique we call it downscaling. In the meteorology and in the climate community, we call it downscaling, but in general public, this means how to increase in the resolution. Okay, so the downscaling technique can translate the global ocean atmosphere signal to local agricultural impact, like this one. So, okay, the concept is we use the Earth system model to identify the mode, control the hydroclimate pattern. Then we will use the physical-based regional climate model to reveal the convective and hydrological details. So then we will have the data over the Thailand over the next week, next month, next season, and also we can get multiple variables for the Thailand. But the traditional physical-based model really take a huge time and resource to do the simulation. In the past 2 or 3 years, the AI data-driven weather climate model are emerged. It is 1,000 times reduced in energy, and at least 10 times faster. In some cases, it's 15 times faster. And the AI weather prediction data is pushed hard by the big companies like NVIDIA, Huawei, Google, and Microsoft. And right now, the performance of the AI weather prediction model is comparable with the physical-based model. In some case studies, even better than the physical-based model. Then the climate simulation is the new challenge now. So in the past years, there are some projects like Climate X by the UCLA and the Microsoft Research, and this one by the Jewish and the KIT. And there are 2 ways to use AI to downscale to increase the resolution of the data. One is embed the global DW model and the regional DW model. And the other way is use the generative AI. This one is developed by the NVIDIA and the Taiwan's weather agency. You can increase the resolution from 25 kilometers to 2 kilometers. So we will have a lot of climate data, but how do we access and analyze them? We want to use the easy way and the checkable way to do this. Okay, in the traditional way, we need to write a program, right? But some idea emerged by the Professor Simon. He offered a course like a use ChatGPT to analyze climate data from write coding to no code. Students like it, yeah. But this is a simple example how to use the ChatGPT to analyze the data. Okay, oops. Okay, you just ask the GPT to analyze the figure. Okay, then it will show you the slightly above the normal presentation. Also, you can ask some quantitative questions, and it will write in some reports. Okay, this can save a lot of time. Okay, but I think everybody the ChatGPT is the general purpose. He's not may not be the expert in the climate analysis. So there are a lot of things need to do now. Like we need to prepare the domain-specific data set, and we need to choose some customer method like promote engineering or RAG. And the most advanced way is the fine-tuning. Use the supervising learning or this dissolution method to make the LLM become the climate analysis expert. So this is the idea of the platform. It's going now. So first, we need to have the AI engine. This AI engine will use the natural language process to interpret user prompt and automatically generate the task. Those tasks is to do like data injection and the data processing, and also like simultaneously, this AI model, it can communicate with any kind of the model, like either the weather model or crop model. Then it can be used to identify the future drought risk or anything else. Also, in the parallel, it can also access the language model like ChatGPT or Gemini to assist them with the impact assessment or automatic report generation. And also, the final result should be assembled and sent to the stakeholder or like a local farmer through like the communication software like a line or email or something. Now, finally, the most important thing is continuous learning. The model should be learn from each feedback and fine-tune itself to be perfect. So this is why finally we should introduce the Kuchi. This is the Kasetsart University Central Climate Intelligence, and we hope it can be as good as the Gucci. Okay. Okay, then is the conclusion takeaway. So I'm talking about climate risk in agriculture, and some talking about the cassava power can relate to the drought. And also I'm talking about like AI can use air power in both fast and energy efficiency agricultural forecasting. Finally, integrate with the LLM to generate a report and automatic crime notification. So this platform can be used to support the decision making. And finally, the most important is the Gucci, developed by the Kasetsart University. Thank you.
Yeah, one question about the modeling in general with artificial intelligence or other ways is how to separate different effects to link the effect of climate, in this case, or weather, with the yields. For example, you showed the graph where the yield of cassava in Thailand is decreasing with a correlation with the drought, apparently. But the time, 2019, 2020, 2021, also corresponds to the arrival of the cassava mosaic disease, which probably also had an effect on the yields. So how to separate the two effects and keep only the effects related to the climate? Thank you.
Okay. They're talking about in some year there's more rainfall and more cassava yield. Okay, they call this we call climate interannual variability of the climate. So this model is not the climate projection model. This model is the seasonal to seasonal forecasting and the interannual forecasting model. So it will forecast like the next year or next season, like the soil moisture condition and the rainfall condition, and can provide the better information. like you can based on this information to selecting the breed, okay, or you can prepare like the irrigation, okay, the irrigation solution to conquer the weather or climate in the future, okay. Thank you.
หากท่านผู้ชมได้รับฟังหรือการบรรยายของดร.เจิ้นต้าช่ายนะครับจากไต้หวันนะครับท่านก็ได้พูดถึงเรื่องการใช้ AI นะครับมาเขาเรียกว่าใช้ข้อมูลทางด้านภูมิอากาศพืชนะครับซึ่งวิธีการก็คือใช้ Open Source ที่มีอยู่นี่แหละนะครับมาดูซิว่าจะช่วยในการตัดสินใจในการปลูกพืชได้อย่างไรโดยเฉพาะลิงก์กับ ChatGPT นะครับเราแค่ป้อนคำถามเขาแล้วก็เราใช้ฟังก์ชันหรือเราเขียนโค้ดต่างๆหลายๆอย่างแล้วก็ใส่ข้อมูลใน ChatGPT แล้วให้เขาวิเคราะห์เองได้นะครับนั่นคือสิ่งที่เรากำลังจะดำเนินการในโครงการมันสำปะหลังของไทยในอนาคตนะครับก็ลองติดตามดูไอเดียก่อนนะครับว่าเป็นอย่างไรก็หวังว่าจะเป็นประโยชน์ต่อท่านผู้ชมนะครับคอยติดตามชมในงานต่อๆไปนะครับในการถ่ายทอดความรู้ของมองโลกมองเกษตรนะครับ